As promised, we're going to be solving rational inequalities. Rational means that the functions are going to be fractions, and most of us do not know what the graph looks like right off the bat. But if we follow these 4 steps, we'll get some idea of what the graph is going to look like, and we'll be able to use that knowledge to find the x values that make this inequality true. Now, just looking at these might be like, whoa, but hopefully if we practice a few of them, it'll make a little more sense. Let's try. So example 1, it is definitely a fraction and an inequality. Our job is to find what x values can we put in this expression and guarantee that the answer is going to be a negative number. Because it says the whole fraction has got to come out less than 0. So the solution to this would be what x values will promise that that's going to happen. Now this is a really nice one because it's all factored for us. Normally that would be part of our job. When it said find the roots, and I left this big space here, that's because usually we will have to do our own factoring. But since it's factored, we can go directly to the roots. In the numerator, if x minus 3 is a factor, well then, x equals 3 is going to have to be a root. And if x minus 4 is a factor, then x equals 4 has got to be a root. And I don't think this marker is going to make it. For the denominator, they have that also factored. If x minus 5 is a factor, x equals 5 is a root. Now this one is actually x minus 6 times x minus 6. This is a double root. It's a double factor, sorry, so we will have a double root. But for the purposes that we're going to use it, we're only going to count it once. Now these 2 roots right here, we are not going to be able to use in our final answer. Because if we put a 5 in here for x, we have a 0 on the bottom. And we know that you can't divide by 0. We're going to use them to get the answer, but they're not allowed to be part of the final answer. Sometimes that happens. They're going to do just as much work as everybody else and not get the credit. So it says, use these roots in increasing order. Well, they go 3, 4, 5, 6. Isn't that cute? And set up intervals along a number line. Okay. Number line. And I'm just going to space the 3 and the 4 and the 5 and the 6. I know they're not evenly spaced. They should be out on the number line. Now we already said we can't use the 5 and we can't use the 6. So some textbooks cross those out. We're going to use them to get the answer, but that's to remind us not to put them in the answer. Your textbook writes a U above these numbers for undefined. So I'm going to put an open circle here because we can't use the 6. I'm going to put an open circle here because we can't use the 5. About the 3 and the 4. Now they're not going to make the denominator be 0. But should we include them? Should there be a solid dotted 3 or an open dotted 3? Well, if we go back to the original problem, it doesn't have an equal sign here. It just says less than 0. So because it's just plain old less than, we will not be including the 3, nor will we be including the 4. Okay, now these 4 numbers, even though we're not going to be allowed to use any of them, break the number line up into 5 separate intervals. However many roots we have, we should have one more interval. So we're going to have an interval here from 3 on down forever. So we're going to have negative infinity to 3. We're not allowed to use the 3. Here we're going to have an interval from 3 to 4, but we're not allowed to use either one of those. Here we're going to have another interval from 4 to 5, and again, we're not allowed to use either one of those. Excuse me. And from 5 to 6 exclusively, and from 6 on up to infinity. So we are going to create a sign chart, a plus and minus chart, to go with one value, either a positive or negative for each one of these separate intervals, which will give us an idea of what the graph looks like. How we get that chart is we pick one x value from each interval and plug it into the factored form of the equation. Because I can't fit all of this on the screen, I'm going to copy the problem down again here. Just the factored form. And we're going to test one number from each interval. We have infinite number of choices for each one. So testing, all we want to do is see, is this going to come out positive or is it going to come out negative? We don't care what the number actually is. So for the first interval, negative infinity to 3, we need basically a number that's lower than 3. I chose to test 2. So just want to know if it's positive or negative. If we put a 2 in here, this parentheses 2 minus 3 is going to come out negative. We put a 2 in here, 2 minus 4 is going to come out negative. On the bottom, 2 minus 5 is going to come out negative. 2 minus 6 is going to come out negative, but we're squaring it. So this piece is going to come out positive, because when you square a negative number, you get a positive answer. So we have a negative times a negative is a positive. A negative times a positive is a negative. Overall, this whole thing is going to have to come out negative. Which means all the numbers from 3 on down to negative infinity are going to be negative answers. Moving on to the next interval. This is not hard, but it does get tedious. We need to pick a number between 3 and 4. I am just going to choose 3.5. Going to put a 3.5 in here for x. That's going to come out positive. 3.5 for this x. That's going to come out negative. 3.5 here. That's going to come out negative. And this one's going to come out negative, but when we square it, it's going to become positive. So we have a negative numerator divided by a negative denominator, which means overall it's positive. So any number we pick in here is going to be positive. Now some textbooks put the positive up here. I kind of crowded there. Then we got to pick one from between 4 and 5. I'm going to pick 4.5. So 4.5 here is a positive. 4.5 here is now a positive. 4.5 down here is still negative. 4.5 here is negative, but when squared becomes a positive. So we have a positive divided by a negative. Overall, it's going to be negative. Oh, we're getting there. In between 5 and 6. I'm going to test 5.5. All right, so put it in here. That's positive. This one's positive. Put it in here. That's going to be positive. This one's going to be negative, but when we square it, it's going to come out positive. Well, that means anything in this interval between 5 and 6 is going to be positive. One more. Gotta test something bigger than 6. I'm going to test 7. So that's going to be positive. This one's going to be positive. This one's going to be positive. This one's going to be positive, and we square, it's just going to still be positive. So whatever number we picked that was higher than 6, forever is going to be positive. Going to get a positive answer for this fraction. So now, even though we don't know what the graph looks like, we know that the y values, the answers are all going to be negative here, they're all going to be positive here, they're all going to be negative here, they're all going to be positive here, and they're going to stay positive here. Apparently the graph bounces, possibly because that x equals 6 was a double root. It was positive on this side, it's going to stay positive on that side. So we have all the information now that we need to solve the inequality. The original inequality said that we wanted this fraction to be less than 0. So we know that we're only going to look at the parts where it's less than 0. And that would be from negative 3 to infinity. I'm sorry, boy, did I say that wrong. From negative infinity to 3. And then union, that means or, between 4 and 5, because that came out negative. So if we pick any number from within these intervals and put it in this ferocious fraction here, our answer should come out to a negative number. And we have solved the inequality.